Hey, Trip Zero here, and this is my first 360 video. So here I am in the office, and I've got here our summer project. Now I am doing summer school with my kids and teaching them a little bit about robotics. So this is what this is. It is a robot. It has mechanism wheels, if that's how you pronounce them right. What's special about the wheels is their ability to move forward, backward, but the way these are angled, and if you spin them the right way, they're also able to move horizontally, forward, back, and side to side. It's actually pretty cool. But let me tell you more about this. So the chassis and the wheels and the motors all came as part of a kit. It was about 140 bucks on Amazon, shipped from China. It took a good while to get here. Very impressed so far. This is aluminum. It's very sturdy and stable. And it's been working pretty well so far. The motors feel plenty powerful. This is rated, I think, engine or motors and chassis at 12 kilograms load. So it can lift something. It can move things. Not a person. You wouldn't want to stand on this thing. You probably want a stronger motor for that and maybe better wheels, because these are very hard. I mean, this plastic is soft, but I wouldn't really push it on hardwood surfaces. What else we got here? So what we have here is a voltage meter. Underneath it is a 12-volt Drock power supply. I'll get a little bit close there. You can see the Drockness. So these are converters. It converts an input of up to 24 volts, but basically a 4S battery. I think it would still work with a 3S battery, but that is the let's see if I can get a better look at that thing. Power distribution board right here, and that accepts the input. Right now it's connected to a wall port, but here is the battery. We'll talk about that in a second. What else we got? So two 12-volt, one to power the front wheels, one to power the back. They're connected to this Drock motor driver, and these are H bridges. If you don't know what that is, it allows, or dual H bridge actually, but an H bridge allows, it's basically a motor controller that flips the polarity of the motor so it can go frontward and backward. And I've got the two back wheels connected at the top, and I've got sandwiched. If you see, there's another one on the bottom. They're stacked to save room, and that is the other one to control the front wheels. This power supply controls the brain of the operation, what we're calling the brain, which for now is this particle photon. This is the PMW controller. We're using 3 of the outputs, so this is basically just to save some space. Didn't want to use all of the PWMs on the particle photon. It doesn't have enough. You need 2 IOs, and you need 1 PWM for each motor. So that's what's plugged in over here. All this mess is one to tell it which direction, 1 IO, digital output, tells it which direction it's going, 1 tells it if the wheel's enabled or not, and then of course the PWM rate tells it how fast to spin the motor. So that's everything connected here, is the IOs to enable the wheel and the IO for the direction, or I should say outputs. They're not quite IO, there's no input. Okay, so another thing I've got here is just a USB out. and that's going to go to a Waze camera that's also controllable over Wi-Fi. Sorry, I should mention the particle photon is Wi-Fi enabled, so we'll control this bot over Wi-Fi, and it's pretty, like, as far as like dumbness is, this is pretty dumb as itself, but we can hook it up, control it over Wi-Fi with a much more powerful computer, and control it from there. So we can get a live stream from the Waze camera, which I'm going to hack the firmware. In fact, I have already done that. Go look in the trash. It's clean in here. Just throw paper in here. So I did have a Waze camera, and I got the polarity wrong, and I burned out the camera bit. But you can get open source firmware for these, and that allows RTSP streaming from the camera. So I will be streaming the video over Wi-Fi and then trying to control it via the particle photon. Now I've written some software that and a protocol to control the motion of the wheels over UDP, Wi-Fi UDP protocols, and not TCP. UDP should be pretty quick and low latency. Unfortunately, the camera will not be as low latency, so that's going to be a little tricky. But we can make it move really slow. The rovers on Mars, they move very, very slowly, and I think it takes, what, 11 minutes to actually send a command to the rover on Mars. This will be, so I can show you how this is mounted. So we could do something similar. Depends on the latency, right? Let's see if we can open this up. Make it stand kind of tall. And then there's a metal plate right here. It just attaches. It's pretty slick. It attaches right there. And it's high enough clearance where it can clear the things in front of it. So that works pretty well. Now the kids helped me put together the chassis. That was good. I've explained to them some basic electronics, like how electrons flow, positive, negative, means the direction, what is voltage, what is current. And then they are going to program a simple exercise. So I've written a Python library to go with the protocol that works with the protocol over Wi-Fi. So we'll connect to the bot, and you can issue it commands. Now, if you've ever played a game called Robot Turtles, it's a kid's game that kind of teaches programming, but you issue commands to these robot turtles, and then they have to go get a jewel. It's a pretty cool game. If you want to teach your kids basic programming, it's pretty good, or at least programming concepts, it's really good. But we're making we're going to play a real-life Robot Turtles using Python. Now, I've been teaching my kids Python. There's some YouTube Python lessons for kids, and my two oldest have been taking these classes, so they kind of know a little bit of Python. But these commands, you know, forward, rotate, they're so simple. Even if you don't know Python, you can just type them and then go. So I can share my protocol and that if anybody is interested, I can post that up on GitHub, no problem. But the protocol is really lightweight, and it's very similar to my light strip control protocol, which is faster and much better than I can't remember what the industry standard protocol for controlling light strips is, but mine is, I think, better. Just because it's, I think you're forced to send a 512 packet, even if it's just got nothing in it every time, if you're using the industry protocol. But anyway, we're not talking about light protocols, but it's very similar in the way you work it. And I borrowed a lot of code, so I was able to do the libraries and things very, very quickly. All right, this is the, we've named it T-Bomb, because it's a combination of all our names. Hopefully I'll have a video of the rover T-bomb going and navigating the maze, and the kids trying out, trying to program it. But that's just a little summer fun project from me to you. If you have any questions, leave comments. Catch you later. Trip Zero out.